go ahead and get started. Okay, so today we're going to be talking about factor strings. Some numbers can be written as the product of several different pairs of factors. For example, 100 can be written as 1 times 100, 2 times 50, 4 times 25, 5 times 20, 10 times 10. It is also possible to write 100 as the product of three factors, such as 2 times 2 times 25. Class? Class?
Yes.
You're way too loud. I can't even hear myself teaching up here. Please use your whisper voices. Thank you. Alright, so I want you to try to find the longest string that you can that has a product of 100. Remember, if it's a product, what operation are we doing?
It equals.
Multiplication. So the longest series of numbers that multiplies up to 100. Go ahead and give it a try.
Bailey, Steph, there's two right here. You will need a marker though.
The longest?
Yep. See if you can find one that's longer than 3 numbers. Okay, what did we come up with? What'd you get, Tom?
2 times 2 times 5 times 5. And it works.
Okay, does it work?
Yes.
2 times 2 is?
2 times 2 is
4.
4 times 5 is? 20 times 5 is?
100.
100. Does it work?
Yep.
Could we go any longer? Yes.
No, because all those numbers are prime, so you can't break them down anymore.
Okay, good. These are all prime numbers, so we can't break them down any farther. What we have just found is what we call the prime factorization. Okay? The prime factorization is the longest string that we can possibly make for a given number. The longest string of factors we can make for a certain number. So, I want you to give this a try. I'm going to give you a number, and I want you to try and find the longest string that is possible for this number. Let's do 36. By the way, in factor strings, we do not use the number 1.
Got it. It has to be just
Alright, so let's see what we came up with. Somebody besides Tom this time. Go ahead, Bailey.
3 times 3 times 2 times 2.
What strategy did you use to come up with that? First of all, does it work?
Yes.
How can we check and make sure it works?
3 times 3 is 9 times 2 is 18 times 2 is 36.
Okay, good. What strategy did you use to come up with that?
I divided 36 by 2.
Okay, so you said 36 divided by 2.
I got 18.
Okay, which would be 18.
And then I divided that by 2.
Divided by 2 again.
And I got 9.
Okay.
And then I divided that by 3. And got 3.
Okay. So then you ended up with, when you got down to these numbers that were prime, then you just kind of added them all together. Did anybody use a different strategy? What'd you do?
What I did, because I know that 6 times 6 is 36, so I just broke the 6's down.
Okay. So you took 6 times 6 and divided it. So you got
3
3 times
times 2.
2 and 3 times 2. Multiply those together, and we get our final product, right? Okay. In today's problem, you are going to be doing a product puzzle. Whoa. The product puzzle is basically, it's like a number puzzle, kind of like number search or word search, okay? And you're going to be finding strings of factors. Now, there are lots of different ways that you can string factors together to make your product, right? At least for some numbers. For some numbers you can.
Connect them all and it'll make
What do you think? Okay, but it's for a specific number. It is for a specific number. In this case, we're going to be doing it for 840. So you have to string numbers together to get the product of 840.
Are those all of them right there?
These are a couple of them. That's not all of them.
Wait, that wouldn't work. 120. Wait. That's the thing.
Okay, so you're going to multiply them together. You're going to find as many strings as you can, and then you're going to answer some questions on it. Write down on the bottom here, write down how many you found, or like which ones you found. Write them out as a multiplication problem. And then you're going to answer the questions.
Wait, for how much? 840?
Yeah, for 840. You may want to write that on there so you remember, but it is in your book as well. All right, and then you're going to answer the questions that are found on page 50. What questions can I answer for you before I let you loose on this? No questions? All right, let's go ahead and get started then.